Welcome to the video. In this tutorial, I'm going to show you how to build a container for a deep learning model and run it on PlantIT in less than 10 minutes. In the first section, we will prepare a container for a deep learning toolkit called Deep Learn Phenomics and push it to the Docker Hub. In the second section, we will create the PlantIT Flow by simply preparing a YAML file called PlantIT.yaml.
Warning: no terminal command and programming language required.
Before we start it, there is a slide coming with this video. You can scan this QR code or click the link in the description below. The slide can be accessed in the browser. Just click the arrows at the bottom right corner or swipe on your mobile device. We are going to use GitHub and GitKraken. Make sure you have a GitHub account. GitKraken is an awesome Git graphic user interface. Click my referral link in the slide or the description below to win a $100 Amazon gift card. GitKraken can not only visualize the development process, but also aid your project management with board and timeline tools. Give it a try. We also need to install Docker. Just go to docker.com. Download and install Docker Desktop. Also sign up an account so that you will be able to upload or push your container to the Docker Hub. Alright, let's move on. First, we are going to download somebody's source code, slightly modify them, and write a recipe for it to build up a container so that we can run it on PlantIT. We are going to use Deep Learn Phenomics. Deep Learn Phenomics is a deep learning toolkit for plant phenotyping in forms of Python package. Here is a quote from their GitHub README. Think of it as carrots for plant scientists. It actually integrates TensorFlow for learning. So it can not only run on both CPU and GPU, but also scale easily across devices. To be more specific, it comes with two main things. One is pre-trained convolutional neural networks that can conduct simple tasks on rosette planes. The other is easy-to-use API for you to build new models. They provide a good document. Here we can see several examples using the pre-trained networks, including vegetation segmentation network, rosette leaf counter, and canola flower counter. We are going to prepare a container for Deep Learn Phenomics and make its application development not only across platform but also reproducible. First, we have to download its source code. You can copy and paste the git clone command from the slide, or clone the repository by GitKraken. Just open GitKraken. In the new tab, click the clone a repo and paste the URL. This repository is a little big, so it will take some time. Then we are going to trim the repository a little bit. This step is optional. Let's take a look at the files. In the GitKraken, press Command or Control plus P. Open in File Manager. I'm going to remove the docs at the root directory and the tests in the Deep Learn Phenomics directory. You can use the rm command from the slide or just delete them manually. Next, we are going to prepare a simple script file. This is a script file that will actually be executed. Let's copy the semantic segmentation tools.py from the example directory of the root directory. Open it with your favorite editor. It is an example script that conducts segmentation on International Plant Phenomics Network (IPPN) dataset. It has a brief structure. First, import some packages, then specify input and output directory. The images variable is a list that takes all files in the input directory that ended with _rbg.png. In the for loop, all of the images will be processed by the network. As you can see, The input and output directory here are hard-coded. We're going to modify it so that this script can take file path as argument from command. You can simply download the finished version from the links provided in the slide. Next, we are going to write the Docker file, which is the recipe for the container image. For this Docker file, we use Ubuntu 18.04 as base image. We installed Python and necessary libraries, upgrade pip3, and use pip3 to install Python dependencies for dplant-phenomics. We put the dplant-phenomics inside directory other module and add this directory. Finally, install dplant-phenomics and add the example script we prepared. I assume that you also use VS Code because we are going to use the Docker add-on of VS Code to build it. Install the add-on and add the folder to the workspace. Press the right mouse button on the page and select Build Image. Input your Docker Hub username / image name : and tag. It will take a while to build it. After building, we're going to run and test it. It is also optional too. Here is the image dataset from IPBN. These are some rosette plants. You can run it with the command from the slide. Here are the results. As you can see, all of the image's background were removed. Next, open the Docker desktop. Select the Docker image and push it to the Docker Hub. And of course, if you insist, you can use docker push command to do this in the terminal. In the second section, please use the right arrow on the slide to go to the corresponding slide. We are going to create a flow on PlantIT. PlantIT is a revolutionary platform for plant scientists. You can run plant phenomics pipelines in the browser without any coding. For research software developers, it is the best place for you to publish your application. Before we start it, sign up a GitHub and Cyverse account to log into PlantIT. Let's initiate the GitHub repo under the tab of init and github.com. And then drag all of the files from the previous section into the repo. Create a new file called plantit.yaml. Use it to specify the name, parameters, and command to run. There is a well-documented instruction on the website of PlantIT, so give it a look. I also write the README file and push them. If you want to make sure your flow would work on PlantIT, you can install the PlantIT command line interface on your own machine. By pip3 install PlantIT-CLI. But we are not going to cover this in the tutorial. If you are interested, leave a comment below to let me know. Let's go to the website of PlantIT and log into your dashboard. Under the Flow tab, we have this new flow published. Let me upload some files to the Cyverse and check in these parameters and run. Alright, that is how we create a container for software and publish it as a flow on PlantIT. How do you think? What kind of plant phenotyping software do you wish to use the most on PlantIT? If you are a software developer, PlantIT is really a best place for you to publish your program because it can definitely increase the chance for other researchers to try out your program. Or maybe you are concerned about the restrictions that may be caused by the user interface of the browser. How do you think? Leave a comment below to let me know, okay? And I'll see you next time. Bye.